Hello. The invention hereby explained is formed by several items linked together by means of a device we will call clamping or fastening cylinder. The insulator with the clamping cylinder displayed is identical to an ordinary suspension insulator, but for the fact that the cap is mostly cylindrical, with a narrowing or groove halfway its height. This insulator can perfectly substitute a conventional one. The second element is the whole robot. It is a self-propelled device able to replace an insulator without having to de-energize the installation. It consists of a central body, dark brown in the model, with a couple of upper arms and another couple of lower arms, here in orange, and the insulator arm in yellow. The ends of the arms mirror the shape of the clamping cylinder for a perfect fit. The insulator arm is also capable of holding an insulator just due to its elasticity, something which will be seen later on. The movements the parts should perform are the ones shown in the animation, that is, opening and closing of the upper arms, plus 90 to minus 90 degrees spin of the insulator arm, opening, closing, and lengthwise travel of the lower arms. A movement of radial approaching and distancing of the hands of the insulator arm in the range of a few centimeters, not shown in the animation, is also required. For its installation, the body of the robot is aligned parallel to the axis of the insulator string. The insulator arm carries a new insulator. The lower arms clasp the first clamping cylinder, which is earthed. By means of the movements shown, the robot positions itself with one pair of arms on each side of the insulator to be replaced, the one in a different color in the animation. Once there, the insulator arm spins so as to secure the clamping cylinder. Grip is attained thanks to the elasticity of the hand of the insulator arm. The cotter of the faulty insulator is removed with the aid of hot sticks. With the faulty insulator held by the insulator arm, the lower arms slowly continue their approach towards the upper arms, so the robot relieves the mechanical load from the faulty insulator. Insulators must have been mounted in the string with their cotters in the vertical plane containing the string, but alternating one cotter downwards and the next one upwards. Thus, with a radial movement of the insulator arm, it is possible to remove the faulty insulator from the string. The insulator arm then spins the other way and places the new insulator in its final position. Once there, the insulator arm completes the installation of the new insulator. The moving arms slowly recede so that the replaced insulator is tightened. The insulator arm begins spinning the other way, leaving the new insulator, which is detached by elasticity. The robot returns carrying the faulty insulator. The following shots show the same maneuver from a different angle. The reduced or simplified robot is a version of the whole robot without the insulator arm, and is 1 insulator spacing shorter. This robot is installed and moves just like the whole robot. In this case, once the robot takes over mechanical load, the changing of the faulty unit for a new one must be done manually by means of hot sticks. If the reduced robot is compared to the whole one, it is plain to see that the reduced one is lighter and short-circuits up to 2 insulators, whereas the whole robot short-circuits up to 3. Fittings with a clamping cylinder are string end fittings which have been provided with a clamping cylinder, just like insulators. One of the main advantages of fittings with a clamping cylinder is that they allow you to change the first and last insulator of the string using the same method as for any other insulator in between. Another advantage of fittings with a clamping cylinder is the possibility to install the whole or reduced robot with greater safety, since it does not stick out so much above the string of insulators when it is installed on the fitting. Further applications follow. The manual tool is a mechanical device that allows you to change 1 or more insulators at a time by means of manual operations. The manual tool consists basically of 2 yokes, copper-colored in the model. The animation shows how the yokes are opened. Optionally, the tool has adjustable guides to make its installation easier. They are shown in grey in the model and enable the coordinated movements of the yokes as shown. The central hole in each yoke mirrors the shape of the clamping cylinder for a perfect fit. The power transmission screws, in yellow here, let us approach the yokes in the same way as the robot approaches its lower arms to the upper ones. The screws must have elements to free them from bending stress, which have not been represented in the model. The length of the screws determines the maximum number of insulators that can be removed in each operation. In order to be used, the tool is aligned with its axis parallel to the axis of the insulator string with open yokes. The tool is then set on the string with its yokes applied on the clamping cylinders of the insulators. The yokes are closed on the cylinders. The bolts of the power transmission screws are turned towards the yokes. Once the screws are sufficiently closed, you can remove the faulty insulator and change it. The clamping cylinder system is extremely useful in the field of live work and with high temperature, low sag conductors. In this picture and the following ones, you can appreciate the application of cylinders in the case of working on a single dead-end string. It is a particularly complex intervention case. The system can be used on any type of string, with the added advantage that clamping is standardized. No adaptation of working yokes to existing yoke plates is required. In this opportunity, the application of the cylinder system on a double dead-end string is shown. You may see that through the use of clamping cylinders, physical contact on the live side takes place in the furthermost fitting from the conductor, that is, the one with the lowest temperature. This is an ideal situation in the case of lines with high temperature conductors. The full original specifications for this patent, with its blueprints and pictures in Spanish, and a summary in English and Spanish, can be found at the address indicated. There, you can find more detailed information about these and other auxiliary components of the system not shown in this presentation. Thanks for your attention.